In this video, we will use the Taylor-Maclaurin series sum and LINEST polynomial regression to generate the trend line and trend line equation of exponential decay and exponential growth model. Begin with the exponential growth, which is exponential decay, which is array formula, exponent of the x values from 0 to 3.2. And here's the trend line and the trend line equation, polynomial to the 8th degree. And since we're drawing the decay, so we add in the negative sign. We factor in the negative sign. So here you have the decay, exponential decay, and the trend line equation to the power 8 or the degree 8. Next, we generate the saturation, which is equal to array formula 1 minus of these y value exponent. And here you have the saturation. Saturates to 1. And the trend line equation of the saturation growth. And then we generate the Taylor-Maclaurin series sum expansion to approximate the exponent, the exponential decay, and the exponential saturation growth model. So we begin with a times x to the power n, where n is from 0 to infinity, 0, 1, 2. So we go to the highest possible. 12 is good enough. And we enter the series sum. So array formula, series sum of the x values raised to the power n, where it starts from k, which is this value, k, incremented by 1, and the coefficient will be this range. Our value for k will be 0 and 1. So data validation, list of items, 0 and 1. 0 if it is decay, 1 if it is saturation. So we have two values, decay and saturation, 0 and 1 for saturation. Now we complete the coefficient. So array formula, negative 1 to the power n, divided by factorial n plus k, n plus k. Enter. So at n equals k equals 1, it is saturating. If it is 0, then the expansion is decay. Next, we calculate the regression coefficients using LINEST. To do that, we complete the 1 comma x matrix, which is a matrix of 8. So begin with the power, which is transpose 0 to 8. So there's no degree of freedom. We have the same rows and columns. And this is array formula of the x values raised to the power 0 to 8. Now that we have the 1 comma x matrix, we can enter the LINEST for the decaying function. So LINEST data y and data x. Enter. Likewise for the Taylor-Maclaurin series sum expansion, which is LINEST data y and data x. And for the saturation growth, which is LINEST data y and data x. Now we have completed the regression coefficients of the decaying and saturation growth model and the Taylor-Maclaurin series sum expansion. If k equals 1, the Taylor-Maclaurin series sum expansion is the same as the saturation growth. And the regression coefficients are the same. And the trend line are also the same. They are the same trend line. At k equals 0, The Taylor-Maclaurin series sum expansion is the same as the decaying. So the red line is on the decaying dataset. And the trend line, the coefficients are the same for the Taylor-Maclaurin series sum expansion and the decaying model or decaying equation. Likewise, the trendline equation are also the same. This completes the use of Taylor-Maclaurin series sum LINEST polynomial regression to generate the dataset and trendline equation of the exponential decay, the decaying model, and the saturation growth model, and the use of the Taylor-Maclaurin series sum expansion to approximate both.